how they're going to work. Fault tolerance, recovery, talk about that a little bit. I want to do a demonstration of RAID, and we talked about some first hop redundancy protocols earlier in the class. Monitor and optimize network performance. Monitoring is something that, yep, we can see. Monitor, look at, check out what's going on. We're going to talk about how to monitor, network optimization tools, and then how to eliminate network bottlenecks. The bottlenecks are really the things that are difficult to find, because what's slowing us down? And that depends on how we're configured, obviously, and what's going on at any given time. Different sections or segments of the network could be the bottleneck at different times. Different parts of the organization, depending on what we're doing, what resources we're running on the system, whether we're doing big file transfers. And when we talk about backups, a lot of people are doing online backups now, and that's going to take some doing. We got some definitions here, and I got these from the test out slides, and they're good things to know. A log, you say, I know what a log is, and you probably do. It's a record of events that occurred on a system. So when we did AAA, we had authentication, where we proved who we are, authorization, when we got permissions to do specific things, and then we had accounting, and that's where the logs came in. Capabilities built into operating systems, and yeah, you look at your Windows system, you can look at logs. A number of them are enabled. There are other logs that are not enabled. And when we get down here, they've got a little exercise that you can do for Windows logs. And they're kind of handy to look at, to know what's there, particularly when you get into managing a network. What can I log that is not already being logged that might help me with what's going on? You find things on these logs. We used to the firewall logs were just absolutely, I'll say, astonishing at the number of attempts, the number of scans that are going on. Guy was going to bring in the logs and show them to a class one time. He was going to print them out until he found out that, I don't know, it was 150 pages or something like that for one day. So logs, lots of information goes in them. The other thing I'd say about them, if you're not going to do log evaluation, don't bother wasting the hard drive space, because they will fill up a lot of space. Even though the little bitty text files, they're going to grow quickly because something's going to happen every day. Log entries are generated in response to changes in configuration. They're generated in response to however we set them up to respond to things. A load tester simulates a load on a server or a service. The load tester might simulate a large number of client connections to a website, test file downloads, FTP site. So what we're doing with a load tester is putting a load on, testing the capabilities of our resources. Throughput tester measures the amount of data that can be transferred through the network, processed by a device, amount of data that can be retrieved from a disk in a specific period of time. What's the disk transfer rate? And if it's not what it should be, then we've got to go look for material that will allow those transfers to take place when they should. Packet sniffer and protocol analyzer, and I use the terms interchangeably. And if we look at this thing, I think they kind of are. Packet sniffer software that captures frames that are transmitted on the network. A protocol analyzer, a passive device that captures transmitted frames and allows you to view the frame contents, and that's the difference here. And that's the protocol analyzer would be a Wireshark. There are a number of others. Wireshark is the one that got to be real popular because it was free and it works very well, and it just it's one of those that just works, and it does a lot of interpretation for us. And when I talk about interpretation, when we look at those things, we'll look at here in a minute when we get to that. When we look at it's telling us what's going on, that's not necessarily going to be the case, because some of them don't really show you the data in words. They don't interpret, and they don't all interpret the same way. So if you're using a different one, Windows has one, There's one called TCP dump, which is a strictly a command line one. It's very efficient, but it's not as complete, in my opinion, as Wireshark is. And again, install it, try it out, see what happens. These are some of the monitoring tools: the network analyzer and network analyzer read protocol analyzer, interface monitor, where we're monitoring what's going on an interface. The story I told you about the movie on the server, that was because somebody was monitoring the interface. Top talkers or top listeners, and this would be who's sending the most data, and there are a number of tools that will allow you to determine that. Top listeners may be who's downloading and stuff, who's doing an awful lot of downloading, who's getting the movies at work instead of getting them at home. Wireless analyzers, SNMP, management software, simple network management protocol, logs and syslog. Syslog is used a lot in Cisco, and we'll take a look at what one of those looks like, because a switch or a router has a very limited storage capability for logs, and a lot of it goes in memory. And instead of taking up the memory or taking up the disk space, we send the logs to a workstation. We have a little piece of software, and it's a very simple configuration, and the configuration is logging and whatever the IP address is of the syslog server, piece of software that's running on the device, so that they're not kept on the server itself. Another advantage is, or the server, the router, or the switch. Another advantage is if the device gets compromised, the logs are someplace else. The last step, clearing the tracks, I think is what we said, wiping out tracks, that a hacker is going to do, one of the last things they're going to do is to delete the logs. And if you ever deleted a Windows log, you can see that the first entry in the next log is who deleted the last log when we do those things. And Seam, which is a software that combines a lot of different things. It's like the UTM, the Universal Threat Management, except the UTM configures those devices, and Seam is going to monitor what's going on. It can take logs from a lot of different devices and put them together so that we can see what was happening at any point in time. And then some physical monitoring tools are available here. Protocol Analyzer, what do? Monitor all of the network traffic. And let me see if I can get Wireshark going here while we're doing this. Check for specific protocol packets. We had one time, we're running Wireshark on the network, a network segment, kept getting the DNS lookup for a particular site. Kept getting a DNS lookup. And that's kind of odd to just keep continually getting a DNS lookup, because usually somebody goes someplace, reads the web page, and hangs up and goes home. But this one was coming up every few seconds, quite honestly. So what is this thing? So you go look it up on Google. What is this thing? And it's a whatever, but somewhere down in the text it says has been associated with child pornography. And that's when, as a network administrator, you just absolutely kind of go nuts, and we got to find this right now. Further after that, and then all of the tools that we've done, so I've got an IP address. What do? I go to my DNS server and do a reverse lookup. What workstation that goes along with that DNS server? So we track it back down, and it actually was in somebody's home directory. It wasn't anything that we feared. It was just some sort of malware that they got and managed to bring it onto the network, because it was an instructor and they had probably a few more privileges than the students did. So those kinds of things, we can detect them. Detect access unauthorized websites, find open ports, review network traffic for clear text passwords. And you can do that. And when you see those things, it's like, okay, we have a problem. We don't have clear text passwords. How about email? Email, if you're using Outlook on your network, you probably have a clear text password. When I talk about interpretation for these things, it tells us the ACK and the protocols and the IP addresses. Some of the other ones are not going to be as clear as that. That's one of the reasons that I really do like this one. We have TLS, Transport Layer Security. We talk about that. Record layer, encrypted application, and here is the data. Here's what encrypted data looks like on this network. So you go down, and again, look at them on your individual network. These are not going to harm you. There are some things that you've got the possibility of that happening. This isn't going to do that. I was just kind of scrolling down to see if I can see anything that looked like an email startup, and I don't. DNS, what does a standard query look like? The standard query domain name system, transaction question queries, www.yahoo.com, class A, type A, class, independent, and then we should get the response here that would tell us what the addresses are that we would use to get there. Just a little kind of going through here. And here's the hellos. This is the transport layer security, the handshake protocol, the server hello, that we are doing these things. Nothing else. This just goes on and on and on. And if you look at this, when I go down here to the bottom, that amount of traffic was 55 seconds. This is what the time is, 0 to 55 seconds. So how much traffic, and this is on a home network, so how much is going on your network? You need to learn how to use these tools to find issues that might happen to you. The flags set in the TCP handshake, the SYN, the SYNAC, and the ACK. Are we getting a complete handshake? Are we getting a half open from a particular location, the particular resource? Malformed or fragmented packets, and then fingerprint systems can all be in these things. Sniffer, and that was an added that we looked at, and I thought it was a pretty good list of what's going on. So kind of the same things here. Collect statistics on overall activity. How much activity is going on? SNMP is probably going to be better on displaying the activity, the amount of activity, the percent of utilization, and we'll look at one of those here in a second. Busy nodes or hosts, yes, we can do that. We can order those things, and I already closed it, but we can order those things to see who is doing it. But again, it's a fairly obtuse way, I guess, of doing that. It's not anything that is going to be absolutely, here's the IP address of my top. I can go to the source, look on it, and then I can look through these things, and the source and the destination here, the 192.168.100.150 is the biggest talker here. You can see that. And the reason it's the biggest talker here is the only thing that was on the network at that time. But you can go up and down here to see who is doing what, and then 192.168.1.150, we can see where that address is going, what resources is it using, what the top talkers here. Network errors, unusual packets. If I see something there, and unusual is not necessarily malformed, it's like, where did that come from? Or unusual packets, unusual activity, what I was talking about. Why am I getting a DNS lookup every 15 or 30 seconds or whatever it was? Reverse engineering proprietary protocol structures, finding and capturing data from specific packets, and the data from specific packets, again, going back to the DNS lookups. Where are they trying to go to? And then we got to go do some other things. Finding potential vulnerabilities and verifying the security functions. And down at the bottom, captures and analyzes network traffic, can read packet headers to determine the traffic patterns, view protocol information in depth, also known as a packet analyzer or a protocol analyzer, and this was originally titled network analyzer. I like the protocol analyzer, and that's me a little bit better. SNMP, and these are the ones I said I have to say these really slowly or I get it. SMTP, Simple Mail Transfer Protocol, and SNMP, Simple Network Management Protocol. Different ones. SMTP, the mail one is port 25. These are port 166 and 167, I think. But it is designed to manage complex networks. It's also managed to monitor the networks. Information gathered by the management software. In it, we're going to have a manager. The manager is going to be the software that's running on a workstation. The agent is the information or the process on the devices that send us the information for these things. The management information base is a list of all of the information that can be sent. It's the interface. It's like a Cisco switch, Ethernet, 100 megabit interface, a router interface, a serial interface, a hard drive on a Windows machine. A trap is an event configured on an agent. The agent, again, is the software that's running on the device itself. When an event occurs, the agent logs the details regarding the event. Logs. So the trap, the get, is a message from the agent that requests information about a specific OID, the ID of the element that we're trying to get the information about. Walk uses a get next, and walk would kind of walk the devices on the individual devices themselves. The get, we have a get. We also, if we're using it to configure stuff, we have a put, the get and a put. The get gets the information. The put would actually modify the configurations. An alert notifies the network administrator, email or text message of an event that has occurred, such as a trap. And this would be something, the alert, certain things happen. You know, we're monitoring the CPU utilization, and the CPU utilization goes to 100% for 5 minutes. Then we kind of want to know about it because something's wrong. CPU utilization goes to 100% for 4 or 5 seconds. We just started an application. If it goes there for 5 minutes, probably something going on that we want to look at to find out what's going on with these things. So remotely monitor and manage devices. The agent software is on the device. The manager is the software application. The OID, the object identifier, and the MIB is the database of the OIDs. The thing on the bottom left there is what an OID tree might look like. Do you need to know anything about it? No, it's just there. So yeah, this is what one of those things looks like. An OID is a string of numbers, and I think that I have a Wireshark that is an SNMP so that you can see what it would look like on the network. And I'm going to show you an SNMP here just in a second. Yeah, SNMP. So when we look at what goes on with these things, discovery protocol, let's just look at SNMP. You also can filter using this, so that you can only look at a particular protocol. So when we get in here, get next, request, and then the whole string of numbers, that's the object ID. That's the object that it's trying to get the information about. And if I go down here, Ethernet, we have that IP version 4 where it's going to. Differentiated services, we don't have anything, so this is a best effort. Nothing is really marked in here. Flags that are used in it. The time to live, protocol, UDP is protocol 17, TCP was protocol 6. They do have protocol numbers. UDP, the ports that are using, we got port 161 here. Actually 160, I said 167. It's 161 and 162. I think these are the get next, and these are all going to be the gets are the 161s, and the answers should be the 162s. But we have those things to do that. The version, we talked about the versions. This is version 2, so it's going to be the unsecure one. And how does it know what to respond to? We have this thing called a community string, which some people say is a password. So you can see how secure this password is. It's in the data packet. The public is the name of the community string. So what I tell my SNMP manager is that I want to get all the traffic that belongs to the community public, and it will then record that information for me. But what an OID looks like, that's it. It's a series of numbers, and that represents a device, an object that these can go to. And what we have over here, the manager, the OIDs in an MIB, again, more letter, object IDs in a MIB, management information base. And the agents are here on the individual devices, and they're sending the information back. So if I am doing it, let me drag this virtual machine over here and get onto it, and hopefully it's been running. I started and if you want to get this one, this is a piece of software. I knew it. It's one of those things. Yeah, it is Passler. If you down here it is. If you go to them, you can get your own version, and you can monitor up to 100 OIDs, 100 sensors for free. They've gotten a lot better. When they first started, I think we could the free one was like 10 sensors. More and more. But what am I looking at here? The probe device, system health. The disk free on this device, no local probe, and I think it's on this machine. 65%. As we go down here, I've got a few other things. Network discovery, the internet, HTTP 176 milliseconds. That's not really very good a response. And I've thought my response has been pretty slow here most of the day. Gateway 192.168.1.1, my default gateway, I get a ping of 1 millisecond. DNS, and it's the DNS server. The DNS lookups are 3 milliseconds on it. 127.0.0.1, the local host, this device, ping, 0 milliseconds, that's good. The CPU load, monitoring CPU load, 15%. Disk free, 65%. Memory, 44%. So we can monitor what's going on with these things. We can also monitor remotely. And this one is monitoring the workstation that I'm working on. And we got a ping time, 0 milliseconds, and that's good. It checked my SSL security check. It's actually done 2. One of them says it's unsat, and one of them says it is sat. So I'm going to go with the good here, the SNMP CPU load. I'm monitoring the CPU, and the remotes, it took too long to try to add a whole. I tried to add some other stuff, and it just said no. What I had going for a while was a router, but it's not running right now. And you can see that ping is red. We're not getting anything. So we can look at that and say, hey, this device is down. So we can look at the devices, and we could look at what's going on with our individual devices. So all bandwidth sensors, what do we want to look at? The object for these things. If I wanted to look at bandwidth, SNMP, WMI, and WMI is Windows management to do those things. Actually, I may have wound up doing that on the other devices. So Windows card, so things that we may want to monitor. The sensors that I was using, all of the sensors, the core health and the reds are going to be issues, obviously, that are going to be problems. And then I have alarms that are sent to me, and I probably got some, and it says that the router here has been down for 77 days. This device, 250, been down for 166 days. So you can see what's going on your network. I'll go back here to the sample dashboard. Gives me a summary of what's going on. I got 5 down, 1 warning, 25 up, 11 paused, and no unusual ones. So we can use SNMP, Simple Network Management Protocol, to monitor what's going on our network. And again, you can configure it to send configuration information also. These are what some of the SNMP outputs might look like. The one on the lower left here, let me see if I can get it out. Now I'm going to get this one out of the way. This is a piece of open source software. This is the kind of thing that we used to run internally to see what kind of traffic we had on all of our different network segments. Who was using the most bandwidth? It's called MRTG. PRTG is the Pressler one. MRTG is open source, displays on a web interface, and it's more difficult to configure than PRTG because PRTG is a commercial one. If you buy it, it's a fairly expensive one. You can get the free one if you want to demonstrate some of these things to yourself. You know, the tools that you can use, that you can monitor with, and there's some of the outputs that you might see on some of these things. The applications defined here. We talked about the application HTTPS, HTTP, different ones down here, how much is going on, the data rates, and what percent of the bandwidth are they taking. So SNMP can be configured to give you a lot of information. And we finally got to the correct ports. Port 161 and 162. One of them is a transmit and one is a receive. The get and then the response. It goes out on the get goes out on 161. We saw that in the Wireshark. The answers are going to come back on 162. Get information, I said put it set. Get and set. I guess that's easier. Both of them end in ET. Get information from the device. Set sends the configuration. Response agent to manager replies, and then the trap or unsolicited messages. The trap are things that we would have configured that something has happened that we want to know a significant change. The memory utilization went out of sight. The processor utilization went to 100% for the 5 minutes or whatever we're going to do. There are 3 versions, 1, 2, and 3. The most used version right now is 2C, the one that you saw in the Wireshark. 3 is the newest version, and it has security. It has usernames and passwords and hashing and all of the security that you would expect when you're sending data that you don't want everybody to see on the network. 1 and 2, little security. 1's really not used anymore. 2C is just known as 2. Clear text community string, you saw that. Not any real security. We had a situation one time where our bosses decided that we didn't need to monitor our network anymore, that they'd do it for us, and we didn't really like it a whole lot. So we put a hub into the network, into the traffic stream, and we had the brand new community string in about probably 30 seconds. So couple of things there to think about. Networking hub, I could see all the traffic. Protocol analyzer, I could see what's in the traffic, and that's where encryption, and you saw what that one encrypted data looked like, just a string of characters. So encryption, big deal on these things. The ability to not allow your users to see everything is kind of a big deal on those things too, because even if you get an encrypted password, and given enough time, you're going to be able to use a password cracker and crack those things. Syslog, we talked a little bit about. Let me get the, if I can get this Syslog server. I think I've got some data in it so we can see what it looks like straight up. Yeah, it supports up to 5. Man, I know that. What we have, and this is from a Cisco router actually, and then had to set, and we'll look at the error levels, had to set it so low that it got all the debug information. But we have the date, the time, the priority, and all of the error messages that these guys get that we're talking about from the routers and the switches are going to have priority. So that we don't have to see all of the less important or just the routine things. We may want to just see the bad stuff that happens. This has got all the routine in it. But we have that, the priority, the host name, and then the message. What happened? Why did I get this? This is actually, this one is a tunnel starting up, and it's a debug, but send registration request to tunnel 0. So it is establishing encapsulation succeeded. This is a process here that we're establishing an encapsulation tunnel itself. Encapsulation succeeded. NHRP successfully resolved to NBMA. So more of these things. This is the next hop registration protocol. That was for those dynamic VPNs, and that's what's going on here. Attempting to send a packet to a destination, so for these things, and then it's up. So we can see in it, recorded on our workstation, all of the activities that are going on that particular device based on the error level that we want to see. Why we want to do that? We combine several resources. We can now do log analysis. You can't even imagine doing a log analysis on a router or a switch, because there's just nothing there to do it with. It will do those things, and we saw, I think, some of those things: the header, the facility, the program that generated it, the severity level, how critical is the event, and then the message details. The one on the lower right there, what are we doing? The syslog messages are sent to a syslog server. Syslog is just a simple piece of software, and this one is Kiwi Syslog Server. If you ever want to play with it, they have a free one. They'll try to sell you one, but they do have a free one. So it sends it to the Syslog server, which is a piece of software run on a workstation. It can send alerts to the administrator, and then we can check the messages. We can now do log analysis. What's going on? Or do we have a problem? And again, whatever severity level that we want to set. And these are the severity levels. It's a 3-bit, so 0 to 7 is what we have here. Emergency, and this is the one that just read that, what it says: an error condition rendering the entire system unusable. And I've often wondered, if the system is unusable, how is it going to send me this emergency message? A serious failure, 1, alert, a serious failure, 2, critical, a service failure, which may become more severe. 3 is an error, unexpected error that causes a specific operation to fail, but not its underlying service. And then a warning, an error problem condition that is probably harmless or correctable, but might need user review. The ones down at the bottom: notice, unusual events or state changes that are not errors, informational, normal, routine, and then debug is additional. Debug is a command that you're given in the on the devices to say, hey, tell me everything that you're doing. And what it does in the debug is sends you, and that's what you saw in the syslog. There was a debug. Everything that in this case the router did was sent to the syslog server. So you may want to configure it that you only want to see 4 up. So you would do the severity level would be 4, and what that would give you is the 4s, 3s, 2s, 1s, and 0s when you do those things. System logs. These are Windows logs. Operating systems do generate their own logs. Applications and services are typical. Windows, I guess it started in 7, I think, does a much more extensive logging than it ever did before. If we open, let me see if I can open Event Viewer real quick, and then we'll take a break. Event Viewer has custom views, Windows logs. We have the application log, And this one's got a whole lot, 26,000. It's not been cleared probably for a long time, or maybe ever. We'll come back to it in a minute, maybe. Security log. All of these things are going to have to do their things. The setup is actually what happened during the setup system. Forwarded events are events that are forwarded to another location, an off-site storage or a consolidation of the logs. Application and services logs, Cisco hardening, and then we get into Microsoft, Windows. And we get a whole list of things that we can look at that can be logged. So when we say, hey, we can look at logs, and there's really not a whole lot in these things. Look at logs. What logs do we want to see? There are a whole bunch of them that we can look at now in the Windows world. Cisco EAP, Extensible Authentication Protocol. These are the extensible protocols: LEAP, lightweight extensible, protected extensible, and hardware events. And I don't remember what FAST stands for, but it's one that they don't use anymore because it tended to be not all that secure. Okay, so we got this thing finally loaded as 26,193 events. First thing I got is a warning. Profile notification of an event unload for component, whatever, and we gotta look these things up. And then the details, the system event, cease trace logging for errors, and I have a whole bunch of warnings, and then some information, user profile service for all of those things. Let's see, none. Outlook did something. The Exchange web service request get app manifests succeeded. So looks like I started Outlook here. What do each of these things do? You got to look at what's going on. Security, more warnings. The security log, Microsoft user account management. Let's see. We logged on here. Security ID. This event occurs when the user performs a read operation on stored credentials in the credential manager. So audit success at 6:58 right now. It validated me. So we can look at, and what you want to look here for the audit successes, you want to look for audit failures. These are users that try to log on. If we're looking at maybe a brute force attack, we're going to have a whole bunch of unsuccessful logons for these things. So system logs for these things. Let's click through this one real quick. This is the syslog message. What we have the date, the timestamp, the facility, the line protocol for this one. The severity level in this one, it was 5. The mnemonic up, down, and then the message text that we had for it. So it is 7 o'clock or practice. But anyhow, let's go ahead and keep going with this thing. So what we have next is the SIEM, which is the Security and Information and Event Management. Big name. What it's doing is, the top one there, aggregation of many sources. It's putting a whole bunch of stuff together so that we can see it all at once. That can be significant because different things happen on the network. Are they related? And if we can see that they happened at the same time or nearly the same time, that can help us out. Is it a cascading event? Did one event cause the other? So correlation analyzes events. Alerts, it can recognize individual events. Log retention, and the big one here is logs for safe or later analysis, and log analysis tools to allow us to look at what's going on our network. So these things, these resources, all available. I don't have one of those to show you. Metrics themselves are resources, use of a host or a network. CPU time, and if I go to one of these that in a vacuum, they may not mean a whole lot. I'm going to go to Task Manager and drag it over here real quick. CPU was 100%, now it's going down. I just started something, and something that I just started was Task Manager. So my CPU bouncing around, and it is fairly high because I got a lot of stuff running here. The Zoom meetings taking quite a bit, and what's really kind of odd is we have the Zoom meetings and the Zoom sharing, and they each get a portion of what goes on. So we can click on this thing and it shows us what is using how much of the resource that we want. Disk utilization is practically zero. Memory looks good. CPU, fairly high utilization right now, but it makes sense because we're doing a meeting and I have a virtual machine running, virtual machine running, and a couple of other things going on this machine. So resources used by the host, CPU time, memory, storage, the different things. The interface statistics, speed duplex settings, and the speed and duplex settings need to match on both ends. If you do a manual configuration on the switch, you should do a manual configuration on the NIC. Other way around, same thing. Bandwidth utilization, how much of it are we using? And how much of it are we getting? I'm sure you guys do a speed test. How are you getting what you're paying for? Sort of arrangement with that. Interface failures or resets for the interface statistics, and then packet loss due to errors, discards, or drops. And packet loss, we have to have a way to manage that. Errors, again, we can use a Wireshark or something like that to try to look at the errors and find which device is producing the errors, who's causing all of our activity. Because when it comes down to it, we're probably going to find that we've got a bad NIC someplace that's causing an awful lot of the problems for these things. Bandwidth used by the specified service, a physical link, or a wireless channel, and all these things are going to be the metrics that we're talking about. Users logged on to a network or a service, and logged on to a service and keeping records, and I probably kind of digress here, but we had, and this was at the healthcare place, used a piece of software in order to, as a Citrix client, to connect to. We're running a Citrix server with a big database on it that they kept track of, and these people went out into the schools and did interviews with students. And when they would come in, they had to connect to the network and update their particular data. So we use the Citrix client. They're not there all the time, but when they are there, there's a whole bunch of them. So we monitor the use, what is the peak use of our Citrix client, so that when we start getting to the limit that we have, we can go with some justification, say I need more. So we had to monitor the users logged on and the services that they were using. All of those things can be useful when it comes time to say I need more money, other than I need more money and here's why. But you need to say not just I need more money. I need more money and here's why. We need to buy this because of. And you're going to need facts in order to justify those expenditures. Performance tracking, and this was what I jumped the gun on with the manager there, that the task manager, that in isolation at any instant in time 100% utilization really doesn't mean a whole lot. What is the trend? How long was it there? Is something causing it? Utilization relative to need. And utilization, when I put a virtual machine on it, I've now got a server running on it and a workstation running on the hardware. I'm probably going to have a little bit higher utilization because I've now distributed or more efficiently, I'm more efficiently using the hardware that's available to me. Baseline, and Windows has the baseline security analyzer. You need a baseline. What are the critical functions? How much resources are you using? How do you know that something is abnormal unless you know what normal is? And that's what baselines do. And that allows us to do trends over time. This is the clients, the Citrix clients that we were using. We could look at the trends. How many were we using on at any given time, on any given day, during any given week, and plot those and see if they were increasing? At what rate were they increasing? When are we going to have to buy more of these things? Find and correct bottlenecks. Bottlenecks are just that, choke points, where we're slowing down the network. How are we slowing down the network? We stick a hub in the network. Based on what we've talked about, we're probably going to slow down the network because we're going to have a lot of collisions. What's causing these things? And all this monitoring, all of these devices that we're talking about can help. Can any one of them solve all of our problems? No. Can all of them help? Yeah, we need to know how to use, or what a lot of them do, so that we can monitor different things at different times with the different devices in order to see what's going on. When we look at packet loss, how are we going to determine that? May not cause a failure. Protocol stack can correct it. Yeah, TCP can correct it. If we have a packet loss, it just says, I didn't get it, send it again. But it's going to increase the latency, the delay, because we've got to wait for the resend. It's going to increase the bandwidth utilization because, yep, we sent it once, now we got to send it again because it didn't get there the way it was supposed to. It will slow down the entire system. And this is what are these things? What can they do? Errors, packets arrive but contain errors and must be discarded. And the reason that little arrow is down there is when I put this in, I didn't get the whole thing. Discards, packets arrive intact but can't be used. Access control list might do it. No route. A full queue. We've talked about a lot of these things. Maybe a duplicate packet. And you can see those many times, I guess sometimes, if you run a Wireshark to do those things. Real-time data may be too late, but access control list. Hey, it got there, and you're not allowed in. And this is where, when we talked about applying the access control list, where we apply the list can be significant. Not only that, not only in the getting it all the way there. Let me do a bad sketch. Maybe what I'm trying to say here, but if we have our router here and we have maybe our us here and our want to go here and some other here, we talked about two types. We had the one that was only on the source IP address. They need to be applied closest to the destination. If we're trying to deny this one, then the one that only does the source IP address, the standard list, is going to be applied here. If we apply it down here, it's going to deny this one, it's going to deny all this other stuff too. The ones that we looked at that has the source and destination IP address, as well as the port that it's using, they can go right here because we have the source address, where it's coming from and where it's going. That way we don't send them into the router or into the network where they've got to be processed to take up some of the bandwidth. So packets arrive intact. ACLs don't have a route, it's going to be dropped to full queue. And we talked about the queues get full, and once they get full, we're just going to be dropping packets because we don't have anything to do with them and that was the queue, the buffer, the send, the SYNAC. That's something that would cause those things. Drops, a general term, packets not being transmitted by a network device, similar to discards. And then collisions, multiple nodes on a shared channel transmit at once, and each needs to resend after it does a random backoff. And again, hopefully we're not going to see collisions, because hopefully we're not going to see a true bus and hubs. A hub is a true bus because they will have collisions. Switches shouldn't have collisions. If you start having collisions in switches, then you need to look at what's going on with your switch, because they shouldn't be there. And they will measure collisions, and you can look at the statistics on them, and it'll tell you how many collisions you have, and you want it to be somewhere around 0. Optimization, and this is one, optimize things. What are we going to do with this thing? NIC teaming. We talked about binding switch ports together, and we talked about binding serial ports together with PPP. NIC teaming, Ethernet bonding, two or more physical connections to the same network. What we do is bind together two NICs, NIC teaming, put them together so that they appear as a high-speed connection. If you've ever experienced, and it's not as bad as it used to, but two NICs in a Windows machine, they sometimes get confused as to which one is using, particularly if one's not connected, and it just sends packets occasionally into the black hole, and nothing happens, and nothing happens, and nothing happens. So you disable the one NIC that's not connected or connected to something else, and we can do that. If we have multiple NICs, we can put them on, in a server, we can put them on different networks, and it can actually route. But workstations, this is just me, I've not had a whole lot of luck with, unless you do NIC teaming and make them appear as a single entity, as a virtual entity. I've not had a lot of luck with them. Spanning tree, we talked about it. It optimized our switching network, allowed us to have multiple physical paths with a single logical path to the root bridge. Load balancing, we're going to look at it in a minute. With load balancers, we have particularly busy website, for instance. We might have multiple physical devices that contain the same information, and the which one actually answers the reply will change based upon the load balancer, what's available to these things. Incoming requests can be distributed evenly or unevenly between a group members based on additional criteria, however we need to do it. We may have multiple devices, but they may not all have the same capability. So we may want to do unequal load balancing on that, so that the one that has the higher capability, more memory, more CPU power, higher speed NIC, that we send more to it, more queries to it than we do the one that, the 10-year-old machine with a 10 megabit connection will make it really bad. Caching engine. Caching is saving previously acquired data for quick retrieval at a later time. So we're going to cache this information. That means it's going to be instantly available. We're going to talk about proxy servers a little later, and proxy servers cache things so that instead of going all the way to the internet, if you want to reuse or somebody else wants to reuse that page, it's available locally, that we don't have to do those things. Bottlenecks. So bottlenecks that affect network performance. And these are kind of like, okay, I didn't need you to tell me that. ID the bottleneck. Is it on a host, LAN, subnet, backbone, wireless, WAN? Where is the bottleneck? Where do we think it is? Traceroute can probably help us out there, because Traceroute gives us the round trip times of the packets that go out there. What type of component? Busy links, hardware performance, server applications, access control lists, a physical interface, interface problems, switching problems. What component is the issue? And then what's our options? Can we upgrade it, replace it? Offload high demand. We can offload, and there are configurations to offload certain processes to different things. Some video cards, offload video from the CPU to the video card. The video card processor is one of the big things, because that takes a lot of stuff. Redundant systems, load balancing segments, quality of service, to where we prioritize the traffic so that the things that need to the real-time applications get the higher priority to do these things. And this is load balancing, and in this case, load balancing would say upgrades not available. That was one of the things that we were going to use back here, is on a host, busy links, what are our options, upgrade or replace. Well, I can't upgrade. I don't have the funds to do that, but I have some resources. Offload the function. SSL, move the overhead to another server. Data compression, compress the packets, and a lot of that happens in the networking itself, and that's one of the ways that we got faster and faster with data compression. Reduces the bandwidth, Health checks, the functionality, check the functionality of each of these. TCP offloading, move resource intensive processes to some other location. Priority queuing, quality of service, and then content caching, store the most frequently accessed content. And a proxy server will do that for us. The load balancer up here, we have internal servers, the load balancer here, the external clients are going here. So depending on how we have it configured, if we had a round robin arrangement, the round robin would send the first query would go here, the second one would go here, the third one would go here. Then we would do 4, 5, and 6 on down the line, round robin, one at a time, until we've done everything that we should. Again, we may have unequal resources back here, so we may want to send a 1, 2, 3, 4, 5, 6 on down the line, those different things. So share the load, load balancers, clustering, and if you play with Windows servers, you can cluster them, load balancing cluster with them, so that they do that. You create a web page or a database or something like that you share. Keep in mind that when you do this, each of these internal servers need to have the same information. Nothing worse than having 3 different web pages here where users get 3 different sets of information. So the information needs to be the same on all of the servers that we're sending the information on. The physical servers, physical resources, we're just using a load balancer, an intermediary here, to determine which one of them answers the question. A proxy server is something that does the work for you. And those of you who may have an IRA or something like that, 401k. I'm trying to start this thing, see if we can look at one here real quick. May do proxies. A proxy is something that acts for us. I thought I had a proxy server, but I don't. Maybe I do. It's not going to tell me anything though. A proxy server will, and we talked about it I think last night, but what happens with it, with a forward proxy, the remote server, here we are, we're going down, we send our query to the proxy server. It then rebuilds our request and sends it to the internet, to the remote server. The remote server answers the proxy server. So our devices back here never actually connect directly to any of the resources out here. So we go back here, it rebuilds the reply and sends it back to me. When it does this, it's going to cache the web page. So that, let's say that this guy goes to the same web page. He doesn't have to go anyplace. It goes here and it sends it the answer right back. When we got our internet with a grand, huge 56K connection for, probably 350, 400 people, it went very fast. And in classes, you tend to use the same resource. So everybody goes to whitehouse.gov. What would happen is the first user that went to whitehouse.gov would go out to whitehouse.gov. It would respond to the proxy server. Proxy server would cache it. Everybody else would just go to the proxy server. They'd be really fast. The first one would be very slow. So not only can we restrict where they go, we can check for viruses on them. There's a number of things we can do. They also will cache information for us, and this would be a forward proxy. The difference between a forward here, I'll call it an overt and a transparent. The regular proxy, you go into the configurations of the browser and configure the address of the proxy server. The transparent proxy acts like a man in the middle. It intercepts the data and proxies for you. when you do that. A reverse proxy goes from the outside in. The reverse proxy here, we have the resources, the remote client, and the remote client's trying to get something that's on our private network. It goes to the reverse proxy, going to be in the DMZ most likely, and it will then query the resource so that these external users from this untrusted network never directly connect to resources on our internal network, on our network. Get too many things open. Optimization, load balancing, and these are just some of those images. Load balancing, we have the ability to do that. Proxy cache, it caches the information, and it does other things that we talked about last night. Quality of service, where we give some traffic priority and other traffic doesn't, and the best effort is no priorities are assigned. This is monitoring performance. This is one, if you've never done this is one that you may want to do. You can do it on a Windows machine. It's just a matter of looking at and adding performance monitors, individual items to the performance monitor, to the perfmon itself. So we have few questions. The next module, fault tolerance and disaster recovery, we're going to talk about the ability to recover, the terminology, the fault tolerance, and then the backup policies. How to do backups and backup policies. And backups are things that are kind of are not, oh, you did a great job. There are things that are routine. They're a pain to do. They're a pain to store. Tapes fail. Tapes stretch. You got to get new tapes. You go on and on and on. But if you have a failure and you don't have a backup, you might as well get your resume up to date, because without them, you can actually put the business out of business because they lose all of the information. The availability and recovery, and we hear these terms all the time, the 5 nines and the 4 nines and the 99 and 99.9 and all that other good stuff. But high availability, the 5 nines, 99.999% availability, and not down, but availability. The system can be down 5.26 minutes a year. So going to have a pretty high uptime with the 5 nines. If we get 99%, that's like a day and a half. I don't remember the exact number, but it's a significantly higher number than you would think. 99%, hey, that's great, right? But in the number of hours in a year, 99%, that means 1% of them you're down with those things. Fault tolerance is the ability to continue in the event of a hardware failure, and RAID is one of those things, and I do want to do a RAID demo on a Windows server. Create them so that maybe by seeing what goes on and how you do it and what happens when we lose one component of it, make a little bit more sense as you go forward. Disaster recovery, the ability to recover from a serious failure in a timely manner. Now, disaster recovery, when we're talking about disaster, we're not talking about, oh, you came to work and a hard drive failed, or the server's down, or whatever that happens. You come to work and the building burned down. That's the disaster. That's what we have to recover from. And those are the terms that you really need to think in when we're talking about disaster recovery efforts. Some terms here, a whole bunch of terms. There are a lot of terms in the disaster recovery. MTTF is a mean time to failure. How long is it going to be before it's going to fail? And this is based on historic evidence, obviously. And MTTR is mean time to repair. How long is it going to take to fix it? MTBF, mean time between failures. The average uptime between failures for a serviceable device. Not all devices are serviceable. Some of them are replaceable. Hard drives we're not going to service, we're going to replace, for instance. MTSI, mean time between service, is the time from one failure to the next, including the time for repairs. AFR is the annualized failure rate. What percentage of the units should be expected to fail within the next year. RTO, and these are the RTO and the RPO are kind of significant things. The RTO, time to cover, how long is it going to be? How long are you going to be offline? The RPO, the recovery point objective. Whenever you come back online, how much data have you lost? At what point can you start from with these things? So a whole bunch of terms here for what we need to do. Fault tolerance, anything can fail. If it stops the operation, it's going to be a single point of failure. And we talked about, I think, VRRP, the router redundancy protocol, virtual router redundancy protocol, so that we had two routers available. One of them goes down, the other one takes over. That's going to be fault tolerance. If we didn't have that, the default gateway goes down, we're down, because we had a single device there, single point of failure for it. Reinforce or eliminate the single points of failure is our objective. Maybe higher quality equipment, we buy the more expensive ones, or error correcting equipment, or we configurations where we have fault tolerance configured into our network. And this one, the example down here, the older CPU cooling fan, the older CPU, if it fails, it's going to overheat and shut it down, and it may actually burn itself up, may destruct. In the newer systems, when the overheating is detected, it's going to slow down the processing, slow down the processor. We're going to slow itself down so that it's not producing as much heat. And these things do produce an awful lot of heat. If you ever touched one, I don't recommend it. Redundancy, backup power. Backup power here, when we talk about that, these are like big diesel generators. The UPSs that we have are for, again, orderly shutdown. RAID, redundant array of inexpensive disks. We configure it that if one disk fails, the system can keep running, depending on which kind of RAID we do. Network redundancy, load balancing we talked about. Clustering is a form of load balancing. Clustering would have been the machines that the load balancer was using. They are very closely related. Virtualization is also a way to have redundancy. Virtualization really makes a lot of things possible. Virtualization and cloud computing complicate and simplify, I think, our lives at the same time. And then alternate sites, if we need them. If something happens to our site, the building had a fire and we need to move it from one location to the other. Power management, actually, before we do that, let me hopefully quickly do this demo for RAID. We have, this is the computer management for this guy. I have down here, if it'll go down here, 3, let's see, the Epic install failed, so I don't need that. We have 3 disks. This is something that I tried, didn't work, so I still have my hard drive here, but I have 3 40 gig hard drives. What I can do in here is I can do a simple volume, which is just a hard drive with no redundancy in it. A spanned volume would connect volumes together. If we have a bunch of small hard drives, we could connect them together to make them a single larger hard drive, so that we'd have a single point of management instead of a whole bunch of them. The striping, or the RAIDs themselves, here is a stripe volume. We'll do a new stripe volume. And you notice that I have an add capability, but I don't have a next, so we'll do disk 1 and we'll add disk 2, and I'm only going to use the amount of space. How much do I want to do? Let's do 100 megabytes, because just to see what goes on. 100 megabytes, and you notice that the total volume up here, 100 megabytes, is 200. So I get 100 megabytes from each of these 2, and it's going to be a volume letter of E. And let's call it stripe, because we're going to, and we'll do a quick format. Quick format doesn't do a whole lot of checking. Let's see, they got to be dynamic disks, so they'll make them dynamic disks. I might as well go ahead and make this one down here. So we've created these things. Voila, we're done. I'm going to convert this one because I'm going to have to do it here eventually anyway. Dynamic disk is a Windows requirement here. Stripe, RAID 0, and RAID 0 we're going to see here in a minute, there's no redundancy. So we do a stripe volume, mirrored volume. We can add, let's add 2 again here. And let's have, we're going to do 100 megabytes again. But you notice it only has a storage of 100 megabytes because a mirror is going to make a copy of everything. And Donald says, this exercise is a simulation on A+002 test. So if you're going to do A+, you're going to see something like this. So this one has 100 megabytes of storage because it's going to have a mirror image of everything. It's going to have a copy. So we'll call this one the mirror. If I can get my keys on the right fingers. OR. And LaMonica says that it sure is. So we create the mirror here, and the next thing, the last one we're going to look at is a RAID 5. And a RAID 5 is going to require, and we'll go to an add here, I still don't have a next, it requires at least 3 disks. It's a striping, and it's going to have an algorithm, I guess, basically. It's going to store information on it so that we can keep running if one of the disks fails. And you notice I put 100 on here. I got 3 disks. I get 200 meg worth of storage. You lose 1 disk's space worth of storage in a RAID 5. And we'll call this one RAID 5. RAID 5, and we'll do a quick format on it. So we have our RAIDs. What I want to do is go in here to the computer, I hope. And we have the stripe, and let's just make a new folder, and we'll call it, I just want something to be here. So we have a folder here called folder. Let's go into the mirror and make a new folder called new folder. It's fine. And go into RAID 5 and make a new folder called new folder. So now I'm going to go back to the computer management, and this one's got all of them on it. I'm going to take it offline. When I take it offline, you notice that my stripe RAID 0 with a 0 redundancy has failed. I have a failed redundancy in the mirror, and I have a failed redundancy in the RAID 5. Failed redundancy, not failed period. So if I go back to these guys, I still have the information in the mirror. I still have the information in the RAID 5. So I can keep running. That's what redundancy does for me. RAID 0, the stripe's going to make things faster. Great for gaming, not so great for backing up. So I can bring these things back online, reactivate the disk if that was actually the only thing that had happened to me, and it would be back up. But in reality, a stripe fails, restore from backup. A mirror fails, or these drives. Now these drives are all physically on this machine. You can, with some of the more sophisticated management, you can do remotes on these with the management, with the storage area network, I believe. I didn't look at the complex ones in that management. These these will be physically on a server, and you can put a whole lot of disks on them. But there are other things like the NAS and all that other stuff that we can configure this type of stuff on. Stuff is a good technical term, right? So RAID, we have these things, and then we have power management. The surge protector, yep, we have surge protectors. UPS, uninterruptible power supply, or power generator. If you have a really system set up for real failure, you're going to have a UPS, uninterruptible power supply, battery supply, that the power goes out, you go on the battery, and then the battery starts the generator, the diesel generator, and then you switch over to the diesel for the significant amount of time. Hospitals are going to be on generators. Emergency services are going to be on generators. So that how much do you need? How long can you be down for if there's a power failure? You guys in Jacksonville, maybe you're going to have a hurricane, maybe you're not, but you know, what kinds of preparations would you make if that were happening to you and you're the network administrator? You know, just something to think about since you have the threat. Hopefully it doesn't get there. I said earlier, maybe it'll go to Miami instead. So alternate sites, and we're going to have sites and spares. We're going to have spares, a hot spare, connected, powered on, ready for a failover. This would be maybe a hard drive. We can have in servers, big servers, you have hard drives which are called hot replaceable, that you can turn them off, take them out, put a new one in. You can have spares in a slot ready to be turned on in case one of them fails. And then we can, if we had a RAID failure, we put a new hard drive in and rebuild the RAID. Cold spare is going to be in the storeroom. A hot site, cold site. Hot site, fully operational, going to be very expensive. A cold site, it's not going to have any hardware in it, power, ventilation, maybe network connectivity. A warm site is someplace between those things. In the hot site, warm site, cold site, and we talked about cloud providers, consider cloud providers for that backup location. Yeah, it's going to cost some money, but how long can you afford to be down is the thing that you always have to consider with these things. And this is the hot site, full computer systems, complete data backups, real-time data synchronization, fully functional in minutes or hours, and they're going to be very expensive to maintain. You're going to have a mirror image. Virtualization actually makes this a lot less expensive than very expensive, but it's still going to, than extremely, absolutely, outrageously expensive to very expensive. A warm site, have hardware, data can be days old or weeks old. Maybe you have your old backups there. It can be functional in 1 to 2 days. It's going to be less expensive than the hot sites. And then the cold sites, an alternate building with power, no hardware or data backups. It's inexpensive. Transfer the hardware and the data. You have to go out and may have to go out and source these things. And it says it's going to be functional in about a week. This may be something you may have a warehouse leased, a building leased. It may or may not have furniture. You may just have an agreement that if something happens, I want to lease this place. So cold site is kind of what cold site is. We don't have anything in it. It's going to take a long time to get it up and running. The next topic is backups. And backups, again, are a big deal. They're a thankless job. They are a pain, but they got to be done. When we look at them, for years we've had this full, incremental, and differential. A full backup backs up all of the files. Let me start command prompts here. I want to look at something real quick. Let's see. I can't remember which command I want to use. Yeah, real quick here. When you do an attrib, you notice all these A's. These A's say that these files need to be archived. So I did an attribute in this folder, so A, and it hadn't been backed up, and it hadn't been backed up. A, and we have all of the others here, the systems and the hiddens and all the other stuff that goes on with the attributes. But the A bit says that it hadn't been backed up. It's important in these different types of backups. A full backups backs up all the file and resets the A bit, the archive bit, that says, hey, it's been backed up. You don't need to do that right now. The incremental backs up the files with the A bit and resets it, and then the differential backs up the files with the A bit but does not reset it. So what does that mean? Let's say on Saturday night, Sunday night, whichever, I do a full backup. So everything has the A bit reset on it and nothing's been modified. If the network fails, I can get it back up with my full backup. I come in on Monday. People do work. Monday night, I do a backup. If I do an incremental, it backs up the files and resets the A bit. So it's going to be quick to do, but eventually it's going to, if we have to restore, it's going to take a long time. Because on Tuesday, we come in and do the incremental. We back up everything that happened on Tuesday. Resets the A bits. On Wednesday, everything on Wednesday. So little increments that it does. If we have to restore it, we restore the full, then we restore the Monday incremental, the Tuesday incremental, the Thursday incremental, the Friday incremental, on down the line. The differential, do the full, same thing. We come in on Monday, people do the work. We use a differential backup. It backs everything that got changed on Monday. Tuesday, people come in and do the work. It backs up everything that got changed on Monday and Tuesday. So it's going to take longer to do the backup the further we get into the week. But when we get ready to restore it for a failure, we restore the full and then we restore our differential. So the differential is going to be quicker to restore, longer to make. Incremental, shorter to make, longer to restore. Snapshot virtual machines, we talked about that a little bit last night, that we can do that. We can take a snapshot, and then if we need to send the machine back, we can send it back to a point in time. The backup types and the create and security, create them, have them. Once you start using an incremental and a differential, you've got to continue using them after the full. So you can't mix incrementals and differentials in a backup set. Security, think about security. Are they going to be encrypted? Where are you going to store them? What kind of security are you going to have around the storage areas for these things? Backup security, and these are the store them off-site, clearly labeled, physically secure. People can't walk in and take off with them. You may want them encrypted. Store and transmit backups as if they were original file. Secure transport, and this is the encrypt. Off-site location, and off-site doesn't mean in a different room in the building, because if it does that, I've seen them in a lot of places, they just put them on a shelf in the NOC. Well, if something happens in the NOC, we have a fire in the NOC, a flood in the NOC, sprinkler goes off. We not only destroyed the equipment where the actual in-place data is, we just destroyed the backups too. The backup off-site should be in a different physical location. Destroy the data on discarded media, so we're not going to have the dumpster diving. File integrity, is there really a backup? I was asked to come in and help some people one time, and they were religiously running the backup, they thought, except there wasn't any data on it. So when you do backups, try to do a restore every once in a while. Be sure that you actually have something and you know how to do it, because when you got to do it under duress, it's a whole lot different situation than if you're sitting down and saying, I need to learn how to do this. So can I restore it? There are two questions here. Do I have data, and do I know how to do the restore? Backup policies, what should be backed up? And typically it's only going to be the data that needs to be backed up. How long should it be retained? The backup strategies, and there's a lot of those. We have the father, grandfather, son, and how often do you do a full? How often do you do this? How long do you retain these things? There are a number of strategies, and you can decide on one of those. One of them is to do a full the first of the year and keep it until the next year, and keep a full each month on down the line. However, whatever strategy that you settle on, you want to do those. And then how are you going to secure them? Who's going to be responsible for them? Are you going to do split the responsibility? One person is responsible for backing up and another is responsible for restoring. And then create and apply a testing schedule. Do they work? And do they work is a big deal. It's really pretty frustrating and not so good for the career when you say, oh yeah, I got the backup, and you start doing the backup and there's nothing there. So don't do that. Try them out when you do backups. We'll talk about incident response. We'll talk about incidents and then how to respond to the incident. It's one of the things that different severities are going to happen, but probably are going to have incidents of some time. So definitions here, and we looked at a number of these already. An asset is a resource, has value. Threat, any potential danger to the confidentiality, integrity, or availability of the systems. Vulnerability is the possibility of an asset being exploited due to the absence or weakness of an asset safeguard. Threat agent is an entity that may find and exploit a vulnerability. A threat vector is the path or means that an attacker uses to compromise a system. And the threat probability is the likelihood that a threat will be exploited. So we have, again, I think we did these a little earlier, but it's kind of a review here. Some other terms, and this is a little more, I guess, specific to what we're talking about tonight, is an attack, an action that intends to compromise an asset by exploiting a vulnerability, and you have to have a vulnerability in order to exploit it. Countermeasure, reduce the likelihood of a successful account. Exposure, the vulnerability of losses from a threat agent. A loss is the damage that we do. Risk, the likelihood of a vulnerability being exploited. Residual risk is the portion of risk that remains after the implementation of a countermeasure. So we're never going to eliminate risk, but what we can do is reduce or mitigate risk. The definitions for getting ready for the policies: a business continuity plan. Appropriate disaster responses allow business operations to continue when infrastructure and resource capabilities are restricted or reduced. Somebody attacks us, can we keep going? Business impact analysis focuses on the impact that losses will have on the organization. And then a disaster recovery plan, the actions that can stop the incident and restore the critical functions. A disaster recovery plan: can we keep going? Can we keep running? Can the business keep doing its job? And it's going to be the DRP, the disaster recovery plan, is going to be a subset of the business continuity plan. A security incident is an event or a series of events that results from a security policy violation. Has adverse effects on the company's ability to proceed with its business. And here we have a couple of other, what are these things? An event, generally speaking, is something changed. A meaningful change to a network state may be planned. An incident is an event or a series of unexpected events, and those are going to be unplanned. So an event, there's nothing really earth-shaking about an event. An incident, yeah, that's a whole different thing. We didn't expect that to happen with it. Incident response goals, we need a policy, a team, and then first responders. And first responders, just like first responders in the accident world, to us, are going to be the ones that are going to get there and investigate, repair, restore. After the first responders, we're going to investigate, repair, restore. They're going to stop the bleeding. And the process up here at the top: plan in, prepare, detection and reporting, assessment and decisions, responses, and then we do lessons learned. And you see the way it's spelled, that's from a British site. Lessons learned. And we do lessons learned. In the military, we did lessons learned, and we learned the same lessons frequently. And you don't want to learn the same lessons frequently. Lessons learned, we want to be able to do it. Some goals: disaster recovery, containing the damage done by the incident, and getting the affected and the critical services online and secure. Business continuity: the business itself maintains operations. We can keep running. The business can keep going. We can keep making or selling the product that we have. Regulatory compliance, and this is one that we're going to ensure that incident prevention and response complies with the relevant laws. And we have some, the HIPAA in particular has some very specific requirements that we have to carry out. Forensic practices, the formal information gathering, and forensics is just that. It's gathering the information in the aftermath of the incident. Another little chart here, we have preparation, detection, analysis, containment, eradication, recovery, post-incident activity. So the process, preparation, tools, and training is a big deal. Identification, detecting when an incident occurred, not only when it occurred, but the severity. And you say, yeah, we can do that. And I go back to Home Depot. They had been under attack for about 18 months before they detected it. It's not something that's going to always be absolutely obvious to you. And that's where the monitoring and the paying attention comes in. Containment, stop the continuing damage. You want to observe as much as possible, but if you see that continuing damage is going to occur, you're going to pull the plug. And pull the plug is, yeah, we can isolate the device, shut it down, whatever is required. But in a lot of cases, you want, as long as there's no further damage, you want to see what's next, what's going to happen, how are they going to do these things. Investigation, the ID, the effects, and the root cause. Eradication, we're going to eliminate the cause. Recovery, restore the resources, and then review the information and available and take action, the lessons learned and the follow-up. Another chart, and this is kind of interesting, is to close the loop of incident response. The IBM X-Force IRS team helps you address today's security threats. So that's the advertisement. 25% before the attack, plan, prepare, test. 25% of companies have a response plan they consistently apply. 25% have a response plan. During the attack, communicate and engage expertise. Communicate clearly and engage expertise. 53% of the companies have had a breach in the past 2 years. That's a pretty high percentage. That's half of the companies. Conduct analysis, and then after the attack, respond. 66% have found lack of planning is the biggest biggest weakness in the attack response. So are we prepared? And when you get to your company, are you prepared? Are they prepared? What can we do with those? And this one is a fairly short